Hello, good morning everyone. So next lesson, next video, that is called next part 2 it is. Okay. So today we are going to discuss about, in general organic chemistry, we are going to discuss about planar and non-planar molecules. Planar and non-planar molecules. So which compound is we have to tell it's a planar, which compound we don't have to tell planar. Okay, which compound will it is in non-planar. We will talk about that. We will discuss about that. Coming to the point is, one simple molecules will be there. You know that a double bond, triple bond, pipe like that. We have to take one example, whatever it may be. So conditions we have to talk with them. So first of all, what is the condition for this? If only sp carbon atom is there, if sp carbon atom is there, totally continually carbon chain is there, na? So if continuous carbon chains are there, each and every carbon should be sp. If sp is there, so this molecule should be in planar molecule. If only sp2 carbons are there in the molecules, that is also undergoes planar molecule. If sp and sp2 both combine, both sp and sp2 combine in a form in a mixture, sp carbons are there in sp2 mixtures, sp2 carbons are there, but carbon chain must and should be in chain, continuous chain. So if sp is there, if sp carbons are there, it is planar. If sp2 carbons are there, it is planar. If mixing sp and sp2 are there, it is also planar. But only one condition is one. But only one thing is, remember that if carbon is sp3 hybridized, so that will undergoes non-planar. You are getting my point? If carbon is sp3, it is not undergoes any planar molecules, it is non-planar. So coming to the cumulin molecules, cumulin means not alternate bonds, continuously double bonds will be there. You observed some molecules there. So cumulin molecules contains continuous double bonds, double bond carbon, double bond like this. So if those are even number of double bonds are there, even number, even means 2, 4, 6, 8 like that. If even number of double bonds are there, what happen? That should be in planar molecule. Okay, if even number of atoms, if a number of double bonds are, if odd number of double bonds are there, that's come under non-planar. Okay, we will go through. Shall we go through some examples? Okay, we will go through some examples. Okay, guys. So I told you that in cumulin structure, I told that even number is planar. So that is not correct. So please make a correction that if odd number of double bonds are there, it's a planar. If odd number of double bond is there, it's a planar. If even number of double bonds are there, that is non-planar. Odd number of double bonds are there, that is planar. You have to remember. So sorry for that. So first of all, one example. It is first question is there. So you tell me, is this planar or not a planar? It is in planar or not planar? Coming to this point, what happens here? Carbon and carbon hybridization. Tell me, what is it? sp2 hybridization. This carbon has sp2 hybridization. This carbon undergoes sp2 hybridization. So what happens is all carbons are undergoing sp2 hybridization. All carbons are, only sp2 carbons are there. So that's why it's a planar. Very good. Done. It is over. Next one. Coming to this one. So this is undergoes sp2. Okay. Very good. Next one. This is undergoes sp2 hybridization. Okay. Very good. Why? Because one pi bond is attached, carbons are there. That's why they are undergoing sp2 carbons. Coming to this point, this carbon, what happens? This one, this carbon is attached to single bond only. That's why sigma bonds are there. It's not a pi bond. Okay, here. So this carbon is attached to 4 different single bonds. That's why it undergoes no zero sigma, zero pi bond is there. That's why it undergoes sp3 hybridization. So here mixing of sp2 and sp3 carbons are there. That's why is it planar? No, it's not a planar. If it is mixture of sp and sp2 carbons, what is this called? Undergoes planar molecule. Okay. So here what happens? It's not planar, not a planar, non-planar molecule. Coming to this point, what happens? Continuous double bonds are there. Continuous double bond means cumulin structures. You know that. Okay, cumulin structures. Okay, listen. So you are getting my point here. Cumulin structure is this. Continuous double bonds are called cumulin structures. Now tell me how many double bonds are there? Now how many double bonds are there? Two double bonds are there. Two double bonds means even number it is. Even number means non-planar structure. It is a non-planar. So coming to this one, triple bond is there. Triple bond means this carbon undergoes sp2 carbon, this carbon undergoes sp2 carbon. One thing is there. So you tell me, coming to the according to hybridization here, this undergoes sp2, this will undergo sp, this will undergo sp2. Sir, it's a mixture of sp2 and sp and sp2. So before looking that rule, we have to go through is it cumulin or not. Okay, first preference we have to go for. By seeing structure you can tell that. Okay, next one what happened? Ethane molecule sp, not sp2 here, sp undergoes sp hybridization. Only sp is there, so that's why it's a planar molecule. Coming to this point, this will undergoes sp2 carbon. I know that. Okay, if sp2 carbons is there, what happens? This will undergoes sp2 carbon. It will undergoes sp2 carbon. So, but what happens to this carbon? sp3 is there. It is also sp3 is there. So, sp3 carbons are there. That's why it is a non-planar structure. Why it is a non-planar structure? It is not only sp2 carbons, not only sp carbons, not a mixture of sp and sp2 carbons, but a mixture of sp3 and sp2 carbons. This will not which will not rule for planar molecule. So that's why it's a non-planar structures. Okay, coming to this point, what happens here? This is a benzene, you know. So if this is a benzene, okay. So what happens? sp2 carbon, all are sp2 carbons. It's a planar molecule. Okay, you are getting my point. Okay. Next, what happens here? Okay, friends. Next structures are given here. Next structures, what are the structures here given? We have to go through. The first structure is what? First structure is that this is structure. So tell me, boys or girls. Next one. This is sp2 carbons. This will sp2 carbons. Okay, I am right. I am writing here. Very good. Here sp2 carbons. Here tell me what is that value? Here carbon is attaching two bonds. One hydrogen will be there. Okay. One minus charge means how many electrons? 2 electrons. It means 4 bonds are satisfying carbon atoms. It means. So I told you that if 4 bonds negative charge is there, so it should be sp3 carbons. But it undergoes sp2 hybridization. Why? Because this molecule has a conjugation. When resonance is present, so this carbon undergoes sp2 hybridization. I told you now. So next one is coming to this one. So this will undergoes like this, sp2 carbon over. So this is a planar molecule. Next, coming to this point, what happens? So this will shift to here. What is there here in nitrogen atom? So here we got lone pair is there. Lone pair and negative charge on a molecule will undergo resonance or conjugation. We consider it is a pi bond, you know. Suppose if pi bond is there, so it will be shifted to, you know that. So this nitrogen will have one lone pair, it will shift it like this. So conjugation is there, so definitely it will undergo sp2 carbon, right? Definitely undergoes sp2 carbon. It's the main problem. Next, coming to this form, already I given a structure like this. So coming to this point, sir, carbon has a 3 bonds and 1 negative charge is there. Total 3 bonds will be there. So that's why it undergoes sp3 hybridization. So carefully observe here. What happens here? What is going there? If it is sp3 carbon, okay, you are correct. But we have to observe once more in the molecule. Is there any conjugation are there? Yeah, is there conjugation? Why? Because this bond will shift out to here. Carbon has how many bonds shifted to here? Double bond, and this double bond, 1 hydrogen attached bond. Oh, total 5 bonds. You know, carbon don't have that much of capacity to attract towards that. So it will remove one bond. So this bond shifted to here. So finally what happens? Resonating structure will be formed. SCH2 minus CH2. It is not a sp3 carbon. It will sp2 sp2 all are in sp2. So that's why it's a planar molecule. It's a planar molecule. Okay. So we will go through next one. Next, coming to this guys. So very very important for this one. So what is this? I think how many carbons are there? Count them. 1 2 3 4 5 6 7 8. So this is called how many ins are there? Tetra ins are there. Tetra ins are there. 1 comma 3 comma 5 comma 7 comma. Totally tetradines are there. Tetra octa. Okay, ins are there. So it means all carbons are undergoing sp2 carbon. Here also sp2. 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 Sir, all carbons are undergoing sp2 carbon. That's why I will give this structure as a planar molecule. If you think like that, no way. It's a non-planar molecule. So it's a non-planar molecule. Why? Because so this is ring form. So in this form, this molecule will not be in stable form. So in this form only it will be stable. Okay, stable. In stable form also it has sp2 carbons. In this form also we can call it as, what is it? Planar molecule? No, yeah. So what happens is there? This carbon is here, this carbon is here. How can you arrange in a planar molecule? Planar molecule means what? On the plane, only in one plane. So what is the arrangement is there? sp2 carbon is there in according to rule. This is the exception. All sp2 carbons molecules will not undergo planar hybridization, planar molecules. But this is a exception case. Even they have sp2 carbons, it will doesn't give planar molecule. So it is a non-planar molecule. You are getting my point. It is a non-planar molecule. You have to remember. Okay. Okay, guys. Coming to this point. So here what happens here? This resonating structure will be given. So in this resonating structure, what about their bond length? So bond length, you know, bond strength. I told you that bond strength is inversely proportional to bond length. Whatever it may be, you know that bond strength. Bond strength means bond strength and inversely proportional to bond length. So double bond, triple bond is stronger than double bond is stronger than single bond, you know that. So for that reason, so what about the order of bond length? Single bond. Okay, bond length order, tell me. Bond length order: single bond, double bond, triple bond. Now tell me bond energy or bond strength or bond order. What is the order? Same like this, opposite to the bond length. Bond length only opposite for that one only. So it is very lonely. So that's why for single bond length will be more. For double bond length will be 1.34 in benzene ring, 1.5 angstroms in. So when it is resonance structure present, it is not a simple molecule, but resonance is there. But if resonance is there, all bonds should be equal. All bonds should be equal. But whatever it may be, above the double bond length 1.34, below the single bond length, middle of the bond length 1.34 angstroms will be there. All bonds are equal. So coming to this point, what happens here? Here also conjugation is there. If bond resonating structures is there, what about that bond length? It is a single bond, this is a double bond. Is it bond length of B is greater than A? No. It is not a simple molecule. If simple molecule is there, okay sir, I can write like that. But what is going there? Resonating structure is there. That's why all bonds are equal. So what is the order for that one? Tell me. What is the order for that one? So all A is equal to B. Okay. Okay, friends, we entered in the organic compounds. So types of organic compounds, you know that. Coming to this chapter, okay, how many types of organic compounds we have to discuss about that. So first of all, you have to listen first of all. So what is going there here means organic compounds. Organic compounds are different types are there. Among this, first one is acyclic. Acyclic means no cyclic nature is there, no cyclic. So coming to this, cyclic structure is there. If acyclic is there, acyclic means acyclic. Acyclic means no straight chain carbons are there like this. Okay, CH3, CH2, CH3. This is acyclic, means not a cyclic structure. So two types are there: saturated, unsaturated. Saturated, unsaturated. Saturated means what? No double bond, triple bond. Without double bond, triple. This is saturated. If you want to take unsaturated, in unsaturated also two types. Alkene. Alkene means double bond will be there. Alkyne means triple bond will be. This is the double bond, triple bond will be there. This is the types. Acyclic compounds are two types: saturated, unsaturated. Unsaturated two types: alkene and alkynes. Alkene means double bond. Alkyne means triple bond. So coming to the next point. Next point, what happens? Next point, what happens here? Cyclic structure. Cyclic structure, you know that cyclic structure. Oh yeah, like this. Whatever it may be, aromatic or non-aromatic, we don't ask that, but structure type is cyclic compounds. So cyclic structures are two types. Okay, homocyclic and heterocyclic. Homocyclic and heterocyclic. Homo means same type of atoms are present in the molecule. That is homo. But heteroatom, different types of atoms present in the same molecule. That is heteroatomic cycle. Heterocyclic. Coming to the homocyclic atom. Homocyclic is two types. First one is aliphatic and aromatic. Aliphatic and aromatic. Homocyclic, what? Homocyclic means same type of. Okay, here homocyclics are two types: aliphatic and aromatic. Aliphatic means you know that no conjugation will be there. No conjugation will be there like this. This is homocyclic. Carbon numbers are there. Coming to the aromatic compounds, if you take aromatic compound like this, benzene is the aromatic compound, conjugation is there. This is aromatic. Aromatic, two types are there. Aromatic are two types: benzenide and non-benzenide. Okay, two types. Benzenide means benzene structure should be there. Non-benzenide means like this. This is not equal to this is, you know, here we don't have conjugation, but here we have conjugation. So this is non-benzenide form. This is benzenide form. Okay. Next, coming to the heterocyclic atom. Coming to heterocyclic atom, what is going there means heterocyclic atom. Heterocyclic atoms are two types. Heterocyclic atoms are two types. Heterocyclic, aliphatic and aromatic. Aromatic means you know, understand that what happened, conjugation will be there, resonance structure will be there. So coming to the aliphatic compound, don't have any resonance. So for example, aliphatic compounds, you take this one. Aliphatic, it is heterocyclic. So coming to this one, I take nitrogen is that no conjugation will be there. That this is heterocyclic aliphatic. But if you take same molecule like this, okay, if you take same molecules, conjugation will be there here. This is aromatic heterocyclic compound is there. So these are the types of classification. So about this is about you have to understand actually what type of organic compounds present, what is the basic of that. So this is the today's class. So we will discuss about this. We will discuss about this in next lesson. Okay, what is acyclic compound? What are examples? Homocyclic, how they are reacting. Okay, which will give aromatic, which will not aromatic, benzenide form, not benzenide form. We will discuss in next video. Okay, friends. Thank you. Bye. Thank you.